We'll now move to topics on generative AI and large language model. This is again one of the very popular topics in these days. So these lectures cover three main parts. The first one is on natural language processing. We will provide a brief overviews, and then afterwards, of course, we will talk about the large language models and how come it can work for text generations. And then we also know that generative AI is not only for text, okay? We will have a thought on it can also be used for generating images and arts. Okay, natural language processing. Okay, you probably heard of that very often in these days. Okay, it's actually talking about analyzing, understanding, and then deriving meaning from human language. We can communicate very well among ourselves using natural language. We want to make a computer that can also do that. Application actually just go more than just chit chat. Okay, that include machine translation, text summarization. You have a long document, you want to make a concise and also precise summary, so that is easy to understand, right? And also sentiment analysis based on my writing. Okay, do I really like the products based on some customer sharing? Okay, do they have some complaints, or what do they say about positive or negative? So that's sentiment analysis. And also question answering. Okay, so whether you can answer questions in natural language. And chatbot in these days, I think is very popular. I don't think I need more explanations. So a lot of applications. So let's zoom in a bit more on chatbot. Okay, so we are using it almost every day. So we type in our sentences. Okay, that become a sentence input to the chatbot. And so then what happens inside the chatbot? Basically, there are two main stages. For stage one, it's trying to understand the sentences in natural language. We call it natural language understanding. Without understanding, of course, we cannot respond, right? So natural language understandings in a chatbot is basically trying to convert the natural language into some internal format. This internal format, only the computer can understand and then process. And afterwards, okay, the computer can start to understand what you're talking about. Based on this internal format, it will move to this stage two. Based on this internal format that they understand what you're saying, it will try to generate response again in natural language, right? So that whoever talking to chatbot will understand the response. So output a response. So what happened inside these two stages? And before we start the details, okay, actually you probably can recall in the very early days of AI development, okay, Turing test was proposed. Okay, it's basically an idea of chatbot. If a real person chat with a computer system, nowadays we call it chatbot, okay, and you cannot distinguish whether this is a computer or this is a real person's. Then it passed the Turing test, right? So the ideas of developing computer system that can chat with human being itself is not new. So back to 1960, for a very early stage of AI development, okay, there's a chatbot called Eliza. Okay, it's developed by some people in MIT. So how does it work? It trying to emulate a Bulgarian psychotherapist. What does that mean? Okay. So it basically carry no general knowledge. It just try to grab some keywords or grab something from the questions that you asked and then try to get response. If you look at this line, okay, you're probably on the left-hand side, you see that, okay, it starts with say, hello, I am Eliza, okay, so you try to greet the user. and then the user say, I feel sad. And Eliza pick up this and then just say afterwards, tell me more about such feeling. It's very general. Okay? But it seems that Eliza is engaging with the user, okay, for the conversations. And then you may say, I do not want to eat these days. Okay? And then Eliza respond, okay, accordingly. What does that suggest to you? So you may recall that sometime when I talk to someone, we did not put that much attention. Then, based on the question that they say or based on sentences they say, we try to, get back to them, respond to them in a similar manners. Yes, okay, seems the conversation is going on, but then it's not really in depth, and then no general knowledge needed. Okay? Just keep the conversations going. And afterwards, okay, to 1995, Alice in another chatbot that was developed by the Lehigh universities, okay, try to answer questions again, okay, but that require general knowledge. If you can follow the right hand side conversations, if you follow and go all the way to the bottom, okay, there's a question score asked by John. John actually is the user. So what is sun? And Alice is able to respond, the sun is a star for our own solar system. Okay, so Alice, this AI chatbot, cannot pick up this information from the conversation. Okay, so it must contain some knowledge about sun and other topics. And so before I move this one, of course, in these days we are using ChatGPT, and we know very well that it contains a lot of knowledge such that it can answer our questions. Let's move a little bit to some chatbot, which are specially designed for customer services. Okay, so Hansen Bank developed one of this kind of chatbot for many years actually, and they call it Haro. Okay, you can try to make conversation with this kind of chatbot designed for customer service. You probably noticed that very quickly this chatbot would like to know what kind of services you want. They may ask you some multiple choice questions. Do you want service 1, 2, or 3? Or there are some chatbots used by, say, e-commerce website. So again, they try the very best to drive you to what they want. Basically, they want you to buy something more from them. Okay, so instead of just having chit chat with you, so the design of this chatbot is a bit different from, say, for those we're using in these days, say ChatGPT, that keep on answering your questions and keep the conversation going. Chatbot for customer service want you to make decisions as soon as possible, right? Okay, so we have some ideas about the developments of chatbots. Okay, so let's zoom in to see what happens for natural language understandings. What are the key steps behind? Basically 4. Okay, the first steps we call lexical analysis, and after that, so it's syntactic analysis, followed by semantic analysis, and then hermetic analysis. So what are they? So stage 1, lexical analysis, people also call it tokenization sometimes. So when you look at the pictures on the right hand side, so if you're given a document, okay, an NLU, natural language understanding, first in this lexical analysis step, we'll divide it into paragraph. For each paragraph, divide it into sentences. For each sentence, divide it into different words, right? So make them ready, okay, so that we can do subsequent analysis. And then you may say, it's very easy to do this, right? I just look at the spacing, then I can do these tokenizations. Yes, for some languages like English. But okay, for example, okay, if you talk about Chinese, okay, spacing is actually not used to that extent. Okay, very often the characters go one by the others. How to segment the terms, okay, from a Chinese sentence? itself is not very obvious. Okay, but anyway, so we leave this to you to think a bit more about the potential difficulties of segmentations, okay, for different languages. Anyway, so lexical analysis try to do this tokenization. And in step 2, we call it syntactic analysis. To learn a new language, of course, we have to some extent, understand the grammar, okay? So syntactic analysis is basically converting a sentence into language, in some language, right? Which means following some grammar, and convert it to some structured description so that the computer can understand, okay? Again, taking examples on the right hand side, it's a very simple sentence. John hits the ball, okay? Hit is basically verb, right? It's an action, okay? Who does this action? John is the subject, right? John did that action. And then John did the action to what? Ball. Ball is basically the objects, right? So if you follow this link, okay, that provided in the slide, actually this is a online website which can help you to derive this kind of structure from a natural language sentence. Okay. So other than this, you also see that sometimes we have different words, but maybe I should say same word but different form, but which means basically the same things. For example, hit, hits. Okay, it's basically a different form, okay, tense, right? For the same word, hit. Okay. So if we want the computer to know that they're actually talking about the same things, okay. So stemming, that I put it on the left hand side, stemming is basically the steps that people perform, trying to eliminate the prefix or the affix of some words, okay, so that all become hits all become the same words, so that the computer knows that, oh, they are talking about the same things. And another simple examples is lematizations. Okay? So, good, better, actually is talking about same things or very similar meanings. Okay, so we can just convert them to some canonical form. Okay? Better to good, good to good, so that the computer knows that they're talking about the same things. So this is the lexical. This is the syntactic analysis. Right? Step 3, semantic analysis. Able to know the sentence structure does not mean that the sentence itself is meaningful. Okay? So let's take another example. So kindness hits the ball. This time I replace John by kindness. Right? So grammatically it's correct. Kindness is not a subject. Okay? But as you know, kindness is a abstract concept, right? Being kind to someone. It's not a subject that can perform the action of hit, right? So semantic analysis, these steps should be able to identify this and notice that this is not meaningful. So probably you need some rules so as to check whether this is meaningful or not. Okay. So after this semantic analysis, okay, making some meanings out of this sentence, we may also come across situations that actually getting the meaning is not very obvious. There are some ambiguity. Again, use the examples on the right hand side. Say within an article it mentioned John likes apple. If the context of this article is talking about a computer store, okay, this apple probably means Apple computer, right? But if the context of the article is talking about a farmer market, this apple is actually referring to a fruit, right? So we also need to make reference, okay, to the context and the sentences before the sentence you want to analyze or the sentence after the sentence you want to analyze, okay, in order to know whether this is meaningful and what is the exact meanings that the sentence is talking about. Okay, we call this step grammatic analysis. And no matter what technologies you will use, okay, we need a computer, okay, to perform to some extent, okay, these 4 steps so as to understand the meanings behind sentences in natural language. And afterwards, okay, as I mentioned earlier, okay, the computer after this 4 steps will have some internal format, okay, describing the sentence that computer can understand. And afterwards, okay, you will use it, okay, for generating responses. Okay. There are basically 2 approaches. I will first talk about the first one, which is very simple, very easy to understand, okay, but unfortunately, the current technologies is no longer using it, but it's still good to understand it. The first approach is rule-based method, and the second one actually is the second parts of this lecture, large language model. Let's talk about rule-based methods. So suppose you can create a lot of concepts using keywords, and suppose you can create a lot of response templates. Then you can use rule-based method to generate response. And then the methods used behind is called pattern matching. So let me explain that to you using again example. When you look at the slide, you see, okay, first step, create concepts of interest using keywords. And here I create a concept which is called manufacturer. Okay, you see I put this a blanket, okay, for the manufacturers, referring to this concept, general concept. And what is that concept about? I put some keywords and assign them, okay, to this concept. They include Apple, Lenovo, Samsung. Okay, so probably you understand these are the manufacturers of computing devices. Okay, based on this concept, okay, we can also create some response template. Okay, here I give another example. Manufacturer, computer is great. Which models do you like? This kind of response. Something is great. Which model do you like? Okay. But then I don't want to repeat this many times, so that's why we call this one a template, and you see this manufacturer. Okay. This concept can be replaced by one of the keywords that I defined early on. It can be Apple, it can be Lenovo, it can be Samsung. But then which one? Okay, when you want to generate a response. Okay. So I basically do a keyword matching in the input. For examples, in the lower parts of this line. So suppose the input, you input a sentence, you say, I like Apple. Okay. And then using a rule-based method, we detect Apple in the input. And Apple, do the matching. Oh, Apple is actually a type of manufacturers, right? According to the concept of interest that you define. So you pick up, oh, Apple, this word, Apple, is actually manufacturer. And then the computer will put this back, this Apple, this word, to replace the concept manufacturer. Okay? And then give the response. Apple computer is great. Which model do you like? If you say, I'm considering Lenovo, instead of I say I like Apple, and then the computer can pick up the word Lenovo and put a Lenovo into this template to replace the concept manufacturer, and then response become Lenovo computer is great. Which model do you like? Okay, if you say I like something else, and I would say as a professional salesman, I would say this whatever computer is great. Okay, so which model do you like? Okay, so this is rule-based methods. If we can create a lot of concepts of interest, and if we can create different response template large enough, maybe we can mimic how people give response, okay, to questions. If you still recall, we talked about the 3 booms, right? When we talk about the AI developments. And expert system is basically referring to boom 2, the second boom. Expert system designed with many rules, and hope that this rule can actually rich enough, okay, to give good decisions, give good suggestions. I think we talked about this a bit, but I want to reiterate this again. Advantages, as what I just explained, these rules can be easily understood, okay? And people can just interpret the meanings of the rules easily. And we also call it interpretable. And then can design the rules, update the rules, modify the rules, okay? Easily, okay? Disadvantage. So how many rules do we need in order that it can perform as well as a human being? It turns out that many. Even we create many rules, you can not the performance actually cannot get close to humans. And then I think we understand in these days the technologies behind ChatGPT changed the game of NLP, natural language processing. Okay, so with a bit more backgrounds on the developments of natural language processing and some concept behind, now we are more ready, okay, to learn more about large language models. Okay. And I will explain a bit the principle behind for text generation. You're very lucky in these days. If you go to the genai.hkbu.edu.hong Kong, then you probably can see the current Gen AI platform provided to you or by the universities. Okay, you now have a lot of large language models that you can use, not only ChatGPT, but also Gemini's, okay, and also Sonnet, okay, and Number, and there are some others that can generate image. We'll talk about that afterwards. So before we move on, you probably heard of this term, or sooner or later you will heard of this term if you try to get a bit more involved in the developments of AI. Okay, I mean generative AI. So you may heard of the term called transformer, GPT, ChatGPT, of course, and LLM. Okay, so let me explain this term to you so that you know their relationship. Transformer actually is referring to a deep learning model which was originally proposed for machine translation back to 2017. Okay. And afterwards, okay, there's another model, special form of transformer called a GPT, and the full name is Generative Pre-trained Transformer, which is specific types of transformer that can generate text itself. Okay, so recall that transformer is for translation. You have to give input some sentences in one language. It try to translate it to some sentences in another language. You need an input. For GPT, actually just generate text by itself. Okay, and of course, okay, this is interesting, but then people want to use it to answer questions, and that's why ChatGPT was developed. Okay? It's basically for you have to input a question and try to get back to you the answers, of course, in high quality like natural languages. And why it can perform so well, we learned about reinforcement learning before. In order to train ChatGPT, it used reinforcement learning. Okay, details I think I probably skip it here. Other than ChatGPT, as I mentioned, there are other types of large language models. Okay, Gemini, Number, Copilot, they're doing similar things as what ChatGPT does. Okay. And large language model is the overall term referring to all these things. Okay, I hope that this provides you a bit more backgrounds regarding the relationships of these terms. Okay, now I want to briefly touch on some very simple mathematics so that you have a more idea what's going on behind this large language model. Okay. I put in this heading, LLM generate tasks using conditional probabilities. What does that mean? Okay, So given a context, okay, in these days we often call it a prompt, right? You type something. Suppose the context is I wish you to. So that's the context, that's something you type in. Okay. So then you want the LLM to generate the next word and then next word. Okay. Basically generate the sentences afterwards. So what the LLM does so as to able to estimate the next word and then the next word and the next word and keep generating a complete sentence for you. Basically, it tries to compare the conditional probabilities of different possible probable words. Next word, I would say. Okay. So, for example, okay, in the slide, okay, so this is a conditional probability. So, given I wish so, okay, so then we can calculate the conditional probabilities that the next word is no, or given I wish to, then you can try to calculate the conditional probability of the word learn as the next word, and so on and so forth. And then rank them, and then find the one give you the highest. Some of you may say conditional probabilities, okay? Can you explain a bit more? Even though, okay, we may learn it in high school, it's okay. So to calculate the conditional probabilities, okay, so probably we can go back to the definitions, again, high school mathematics. So if we are given some new informations, B, and then the conditional probability written in the way that, okay, probability A given B, okay. To calculate that, I show the formula here, okay. You can first count, okay, in your data, how many times A and B appear together. And then divided by how many times that B appear, then you can get this conditional probabilities. Okay, so I'll give you an example. Okay, so if you want to know if I got a fever, given I got a fever, how likely that I actually got a flu. Then actually from the data, from the patient data, then you can count how many patients got flu and fever together, and then divided by the numbers of patients that they had fever, then you can get these probabilities. Okay, so I hope that is not too hard for you. Okay. If you agree with me, okay, this is a way to calculate conditional probabilities. Then in principle, we can do it this way, right? So conditional probability of the word no, given the prompt I wish you to. So I can count, okay, in a big corpus or a big collections of documents. Count how many times I come across I wish you to know. Okay, how many times I encounter this phrase, and at the same time count how many times I encounter I wish you to. Okay. And then do a divisions, then you can get this conditional probabilities. Okay, you can think about this. Okay. Of course, the denominator is smaller because you need the 5 words to appear at the same time. Okay. And then the denominator normally is a little bit larger because you only require 4 words appearing together. Okay, so if we can calculate this, then easy, just counting, right? Computer can do counting very efficiently. Okay, so we can then just do the counting, calculate probabilities, and then so on the left hand side you see that, okay, so the input in the middle, input I wish you to, and then calculate all these conditional probabilities, and then the next word no will give the highest value, and then the system will output I wish you to know. Okay, and this output will become the input again. Okay, I wish you to know become the input again. Okay, and then we calculate the conditional probabilities using a new context. Now the context is I wish you to know. Okay, and then calculate the conditional probabilities for all the possible words. And then, for example, turns out that the word that turns out to be the highest regarding the conditional probability. And then this large language models will output I wish to know that, and then the generation can continue. At this point, I want you to see that is the probability that is working behind to generate all the words. And interestingly, it does not do any very high level analysis, okay, other than this probability, conditional probabilities. But we all know that it's performance is pretty good, right? It's very impressive in these days, okay, that we know. But okay, then you say very simple. The technology behind is very simple, okay. The key challenges, okay, in case you want to know a little bit more, counting all these combinations is very, very hard. How many combinations can we have for different words in different sentences of different length? A lot, right? And that alone, that okay, for this counting is actually better to consider also the syntactic, semantic, grammatic. Okay? All this, okay, we have to reflect by this conditional probability. Very, very difficult. Now, what is the magic behind LLM to make this very, very hard problem of calculating the conditional probabilities possible? It's transformer. Okay? Okay, let me remind you again, transformer is a deep learning model. Okay? I don't require you to know the detail, the architectures and whatever of transformer, but this is the magic behind. Okay? Magic means the technologies, hardcore technologies behind large language models. Okay? You can carry out the syntactic, semantics, grammatic analysis, okay, all together at the same time can estimate the conditional probability. Okay. And do we have to write the program to do this? It uses machine learning that we learned before. It just needs a lot of data and then train the models. And the models can understand and then can generate response for you. Okay. And that's the magics behind large language model. Okay. And whenever we talk about large language model, people always ask, so what's the length of context that you can consider? So how much you can remember what I have said before so that you can start continue the conversations with me or answering my questions. Okay, it's the length of the context. So take an example. If we're trying to estimate the conditional probability of the word no, given I wish you to. So I wish you to actually is the context. So the length of the context is here for the example is 4. So what's the typical context length used in large language model? So these are some statistics I obtained from the ChatGPT website. Okay, so there are two large language models that we can use, okay, provided by our university. One is a GPT-4o, and now one is a ChatGPT-4o mini. So they use this GPT, okay, for the ChatGPT systems. So can you look at the context length? 128K tokens. Okay, it's very long. 128K, very, very long. Okay, so that is when you make conversation with this ChatGPT. Okay, conversations keep going on. All these conversation history can be stored in a context, and we can calculate the probability of getting the next one based on a very long history. Then you may ask me, token, are you talking about a word? Okay, So if you recall the discussions on natural language understanding, okay, for the very first step, lexical analysis, we say that, okay, we have to divide the whole chunks of words into tokens. Okay, for say ChatGPT, okay, token actually is not necessarily to be a word or only a characters. Okay, so give you an examples. So for the sentences, ChatGPT is great. Okay, according to the way of tokenization used by ChatGPT, okay, this sentence will be tokenized into ChatGPT is great, and exclamation marks. Okay, so there are some reasons behind. It's actually based on how frequent these consecutive characters appear, okay, in a large collections of documents. As a rule of thumb, okay, if you want to calculate, okay, so how many words can the ChatGPT understand? You can understand it this way, okay, one token actually corresponding to, on average, 4 characters in English. Okay, so 100 tokens basically talking about around 75 words. Okay, so with that, you know more than just I can use ChatGPT used for natural language processing. You know a bit more about large language model, what's happening behind ChatGPT, and what do we mean by natural language processing. Okay? And I want to end these lectures by emphasizing that generating text is just one possibility. Okay? In these days, I think we all know we can also generate other forms of output. So this picture actually was generated by me, okay, just before I make this recording. Okay, it's the Chinese New Year, so that's why I generate this picture. Okay. So of course the questions, okay, before having this kind of image generation system, the question that people ask is, we know that natural language processing contain 2 stages, right? Natural language understanding and then natural language generations. Can we just keep natural language understanding? I understanding the inputs of some typings. But for generation, instead of generating natural language, can we generate image? Can we generate music? Can we generate video? Can we generate something that you can imagine? The answer is yes, of course, right? So these are some existing models. There are different models for image generations. Okay, for some years already. Okay, the DALL-E, Midjourney, Stable Diffusions. So all these are different models. Okay, people developed it to generate image, generative AI. Okay, so I tried this very simple prompt: photorealistic cat in suit. I don't think they have built images, okay, or having a cat in suit to train the models. But somehow, okay, this generative AI model can generate cats actually really have the suit putting on. Okay. So that's make the whole things very interesting. That is, you can generate something that probably we haven't encountered before. And so I hope that you can actually try it yourself. You can go to the genai.hkbu.edu.hk, and you probably know after logging in, you notice that other than this large language model, there's another one which is called Adobe Firefly. Okay? And then this is the prompt that I give this Firefly. A happy snake celebrating a Chinese New Year in cartoon style. And so this is one of the generated image. Of course, without the words. Okay, I add the words afterwards. Okay, using number tools. So Firefly actually is make use of a stable diffusion model. I mentioned before, there are different models for image generation, right? Stable diffusion is actually one of these models. Different company can make use of the similar technology to provide image generation services. Okay? And Adobe Firefly should make use of stable diffusion for the generations. And you can just do it yourself and try. Of course, my generated pictures is, well, not very professional in some sense. Okay, at least artists may think that it's just a cartoon creation, right? And some people actually make use of generative AI to come up with pictures like this. And that picture, you may heard of this news, boom, okay, in fine arts competitions. Okay? Then leads to the more philosophical questions. Can AI create something better than human being? Okay? So we'll leave these discussions later on, okay, in the second part of this course. So to summarize, okay, this lecture we touch on natural language processing. There are two stages, right? By now, I hope that you can remember by heart natural language understanding and also natural language generation. Okay, there are several steps, okay, involved, and the magic that make the natural language chatbot so powerful in these days is the transformer deep learning model. For generating images, people use diffusion model, which is actually one of the most cutting-edge AI model that can generate images. Okay. So with this, I conclude this lecture. Thank you.